Hello guys, this is Daniel. We are going to continue with our token contract. Today we are going to make our token more compliant with the ERC20 standard. Remember that for following these videos, it's very important that you have some knowledge of Brownie. So if you feel a little bit lost, go back to one of our previous series where we discuss Brownie in a lot of detail, and also the Web3 Python library. Those are our main tools for working with Vyper. Now, for the naive implementation of our contract to become an actual ERC20 implementation, we're lacking a couple of things. We are lacking a good way to allow other smart contracts to interact with our token and implement the don't call us, we call you pattern, which means that when other smart contracts interact with our token, is those smart contracts that will be calling functions in our token to change the balances, and not our token that will be calling them or sending tokens to them specifically. We are not going to allow other smart contracts to have tokens transmitted to them directly. In an ideal case, we are going to just give them permission to manipulate the balances in our contract under certain circumstances. So that's the most complex functions that we're going to be working on today are going to be those functions regarding to that. We need to also have a good way to deal with decimals, and we need to have some events that are going to be generated in key specific moments of the execution of our contract. So let's go to it, and let's start by checking what we have right now. So we have all of these functions that allow us to transfer funds right now and view the state of our contracts, but we need to implement our new requirements. So one of those requirements is that we have to be able to manage decimals. So we are going to establish another constant here that we're going to call decimals. And this decimals constant is going to be of type uint 256, and is going to be equal to 18. We are doing this because it's usually a best practice that our token has the same amount of decimals as Ethereum. Now, what is going to happen is that this total supply has to change, right? Because right now, if we want a billion, we need to have our token here as 10 to the 9, which we have before, plus the number of decimals that we want, right? That's 18. So we want this to become 27. So this is our current balance here, but remember that this is coming from amount of tokens we want plus the decimals. And we're going to put here 10 elevated to the amount of tokens we want, which was 1 billion, plus the decimals. So this is what we have here. Now that we have that, we also need to start creating the other functions that we will need for interacting with our contract, or better say, allow other contracts to interact with our contract. There are some things that we are going to change here, and one of the things is that this transfer function that we have here, we are going to make it only internal, because we are going to need it for other external functions that we are going to create. So we're going to make this one internal, and for signaling as internal, we're going to mark it like this. But when we make one of these functions internal, we don't have access to the message sender. So we are going to add another from here that's also going to be of type address. And we are going to refer to this from when we refer to these things, to this hash map here. So we're going to do from amount. It's the balance is not enough, and this is basically who is sending the funds to whoever is receiving them, which is the 2. and then we're going to do this here from. And since this one is becoming an internal function, we are going to remove the return statement here, and we're going to remove this one. It's not going to return anything, it's just going to perform some calculation. Now, the other thing that we need to add is that we want to allow other smart contracts to interact with our contract, basically move balances around. What is the use case for that? Imagine that there is a DEX, right? And we want that DEX to transmit or trade with our tokens on our behalf. So for that, we'll have to give them permissions. And those permissions are going to be tied from our own account to the account of the DEX and to a certain amount. And that is another type of hash map that we need to create. So let's create that hash map, and that one we're going to call allowances. And this allowances is going to be equal of a hash map. And this hash map will point to our address in that case, or the address to whoever has an account in our smart contract. So it's going to be address. And it's going to return another hash map, which is going to be mapping the addresses of whoever we are given permission, or whoever we are given permission outside of this primary address that we have here, that we are going to call the owner. This is the sender, or the delegate, if we want to call it like that. And this delegate is also going to have an address, and that address is going to be mapped to a specific balance of token that he can manipulate on behalf of this owner, and that's an integer here. So that's the hash map of allowances. Now, what it's going to happen is that we need to be able to allow this spender or delegate to move funds on our behalf. In other words, we want to give him permissions, right? So for that, we are going to create another function that is going to be an approve function, and we are going to call it below our transfer function, and it's going to be very similar. It's going to be internal, and we're going to define it as def approve, and it's going to receive an owner, which is going to be of type address, and a spender, who is also going to be of type address, and an amount, which is going to be an integer on sign of only positive, that is going to be a 256. And what it's going to do is that it's going to approve an allowance from this owner to this spender, of the amount that is being set in the parameters. And this is granting the permissions. Now we need a couple of external functions that we need to create. To begin with, we need to have a transfer that is external to be accessible from the outside, and we are going to create that one as external, and it's going to be def transfer. It's very similar to this one that we have here, but it's just going to be without this hyphen there, or underscore. And that one, it's going to receive as parameter only the to address, which is the destinatary of the funds, and then we're going to have an amount that is going to be a uint, and this one is going to return a boolean because it's an external function, so we want to return true if it was successful. And what we are going to do in that one is something very simple. We're just going to use this external to call this internal over here. So we're going to do self transfer, and we are going to do a message sender, because in this one we do have access to the message sender, and in the internal function we are expecting a from. And the other one, the other address is the to, which is the person that these funds are going to be wired to or transferred. And then we need to define the amount, so we have the amount here. So this is it. We have it ready, and then we just return true if everything was executed correctly. So this is the first of the functions that we need to have. The other function that we need to create is the external approve function. So it's going to follow a very similar pattern to the one that we have above. It's going to be def approve, and this one is going to have only the spender, is the person to whom this allowance is being authorized. It's going to have an amount, and is going to have a uint 256 and return a boolean. And this one is going to have a self approve message sender and spender and amount. As you see, this one is very similar to the one that we have above. It's just calling the approve internal that we have here. Then let's have return true. And then we have to create another function, which is the one that will allow this spender that has been approved here to actually move the token. So we're going to create an external transfer from, and we're going to have, in this one, we're going to have an owner, which is going to be a type address. We are going to have a to, which also is going to be of type address. We are going to have an amount, which is going to be a uint 256. It's going to return a boolean, and this one is going to have some checks that we want to make at the beginning. So the first one is that we are going to assert that self allowances of the owner to the message sender, which is whoever is calling this function, is greater or equal to the amount. And if this is not the case, we are going to return the allowance is not enough for this operation. And we're going to have another assertion here that is going to be self balances owner only, because we are just going to check the balance of the owner, and we're going to write that the amount of this balance should be greater than the amount that is being trying to transfer. And if that's the case, if that's not the case, then we're going to say the balance is not enough for this operation. Now that we have these checks here, we are just going to do the following. We are going to transfer the token, so we're going to do self balances of owner is going to be minus equal of amount, then self balances of 2 is going to be plus equal amount, and we are going to set the allowances. So self allowances of the owner to message sender, who basically the one who is activating this call, should be reduced, right? Because he's utilizing that amount of allowance, so we are going to reduce his allowance by that specific amount. And if everything went correctly, we're going to return true. And this will allow our smart contract to interact with other smart contracts in an ERC20 compliant way, which is the other contracts will have to use this transfer from function, and the owner of the funds should have some approvals to those smart contracts to move tokens on their behalf. And we need a couple of view functions here that we have not implemented. So we are going to implement them now. We are going to implement one external view to see the allowances. So we're going to have external view def allowance, and we're going to say owner address spender address, and it's going to return an integer, and this one is just going to return self allowances of the owner to the spender. This would allow us to check what is the state of the allowances. The other thing that we need is that other people might want to be able to see clearly how many decimals our contract have. So we're going to have these decimals. This one is not going to take any parameter. It's going to return a uint, and it's just going to return our decimals constant. Now, the ERC20 standard also establishes some events. And if you are not very familiar with events, go back to our series on Vyper, the initial series that we have on general concepts of Vyper. In the advanced topics, we make a very nice walkthrough on events. But here we're going to create two events, which are the ones that the ERC20 standard requires. So one is going to be the event transfer. And this event transfer has the following, has a from, which is an indexed address. It also has a to, which is also an indexed address. And for those that have not watched the previous series, what it means in events to have indexed fields is that you can perform searches on those fields that are indexed. So in the addresses here, I could go to fetch what events are related to a specific address. So that's the reason these are indexed. So let's go and create the other one, which is value. And this one is just a uint. And then we have another event that is called approve and has similar fields, but just with a different name for clarity's sake. Instead of from is an owner, and instead of to is a spender, and then value and value. since we have events, we should be able to trigger those events, right? And we are going to do that in our internal functions here. So what we're going to do is that in our transfer internal function, we're going to have a log transfer, and we're going to have a from to an amount. And in our internal approve function, we're going to have a approve event, and it's going to have an owner, spender, an amount, which is value in our event definition here. So having those two events created, our ERC20 token is compliant right now. So we're going to deploy it. So we're going to Brownie console. And we have one of these annoying, super annoying actually, syntax mistakes that make you look for hours, but let's just clean it right now. And then let's try to deploy again. So we're going to do Brownie console. We have there our deployment. So now we are going to do token. We're going to do hello world coin deploy, and for deploying we need to send it from an account. So we're going to have our curly brackets here. We're going to define our from field, and we're going to send it from accounts 0. We deploy and then check the balances. So we're going to say from this deployment that we created, balance off, and we are going to put accounts 0 that address, and this has all the coins right now. And now we're going to do something interesting. We're going to use the functions that we created. So first we're going to do approve, and we're going to approve the accounts 1 address for an amount of 10 times to 10 to the 18, which is 10 units of our coin, on behalf of account 0. Then we have it right now. Now we are going to check the allowance. We are going to say allowance. First we have to send the owner. Then we send the spender, and here we have the 10 units of our coin. Now we can do transfer from account 0 address to account 2 address, and we're going to send this transaction as if it was sent. We need to send an amount, so we're going to send 2 times 10 to the 18, and we're going to send this one from accounts 1, which is the one that has the allowance. Now we go to the balance of, and we're going to do the accounts 2 address, and then let's do divided by 10 to the 18 to give us the units of our account. Those are the 2 coins that we submitted. So as you can see, our ERC20 token is working as expected, and in the following video we're going to manage the supply in a more interesting way. Thank you very much, guys. This was Daniel. Sign up to the Moralis channel and follow this series, and don't forget to smash that like.